Consider a complex number z with absolute value 5. The absolute value of z minus 6 is 7. Question: what is the absolute value of z minus 2? Agenda. First, we are going to review the definition of absolute values of complex numbers. Then I will present our first solution using complex conjugates. I will also discuss the geometric interpretation of absolute values, the distance. Then I will conclude the video by another solution using Pythagorean theorem. Let's review two concepts: absolute values and complex conjugates. Let z equals x plus yi for some real numbers x and y. X is the real part and yi is the imaginary part of the complex number z. The absolute value of z is defined to be the square root of x squared plus y squared. The complex conjugate of z is defined to be z bar equals x minus yi, switching the sign of imaginary part. These two concepts has close relation. The square of the absolute value of a complex number equals the product of the number and its complex conjugate. This can be easily verified. Let's solve the problem. First, we have z times z bar equals 5 squared, which is 25. Secondly, we have z minus 6 times the conjugate of z minus 6 equals 7 squared, which is 49. Expand the left-hand side. We have z times z bar minus 6 times z plus z bar plus 36 equals 49. Plug in z bar equals 25 and simplify. We have z plus z bar equals 2. The sum of a complex number and its conjugate is always a real number. Finally, we calculate z minus 2 in absolute value squared. Plug in the definition, expand, and plug in z times z bar and z plus z bar. We have 25. Therefore, z minus 2 in absolute value is 5. The solution using complex conjugate is certainly clever. Moreover, there are geometric intuitions behind the calculations. This leads to the next topic, a geometric solution. Each complex number corresponds to one point on the complex plane. A pair of conjugate numbers is symmetric to the real axis. If we have two complex numbers, the absolute value of their difference is the distance of their corresponding point. Bearing these observations in mind, let's look at the problem again. First condition, absolute value of z is 5. In terms of distance, the distance between z and 0 is 5. All such z form a circle with center at origin and radius 5. Another condition, the absolute value of z minus 6 is 7. This is another circle with radius 7. Therefore, intersections are possible values of z. You can see that the whole picture is symmetric to x-axis. In particular, the two intersections are a pair of complex conjugates. We need to calculate the distance from the point 2 to these 2 points. This is plain geometric problem. We can just look at the triangle. Triangle ABC with AB equals 5, AC equals 7. These are the radius of the circle. And BC equals 6, BD equals 2. We need to find AD. We draw an altitude of AE of the triangle. The point E separates BC into 2 parts, BE denoted as X and CE denoted as Y. Immediately, we have X plus Y equals 6. Applying Pythagorean theorem to the two right triangles ABE and ACE, we have AE squared plus X squared equals 25, and AE squared plus Y squared equals 49. Therefore, Y squared minus X squared is 24. We already know X plus Y is 6. A simple division will give us Y minus X equals 4. Y plus X is 6, Y minus X is 4. Therefore, BE, which is X, equals 1. Now we can see E is the midpoint of BD. Therefore, triangle ABD is isosceles. So AD equals AB equals 5. Thank you for watching. Please consider subscription of my channel. I appreciate your support.